This is my forces and circular motion reassessment. A child pushes a merry-go-round from rest to a final angular speed of 0.5 revolutions per second with constant angular acceleration. In doing so, the child pushes the merry-go-round 2 revolutions. What is the angular acceleration of the merry-go-round? So my angular velocity initial is 0 radians per second because it started from rest. And then my final angular velocity is 0.5 revolutions per second. The total angular displacement equals 2 revolutions. And I got this formula off the formula sheet, and I have angular velocity, final angular velocity squared equals initial angular velocity squared plus 2 angular acceleration change in theta. So then I change the equation up to get both angular velocities on the left hand side of the equation, and I solved for angular acceleration, which gave me angular velocity final squared minus initial angular velocity squared divided by 2 change in theta. And then I substituted for the values, and that gave me 0.5 revolutions per second squared minus 0 revolutions per second squared divided by 2 times 2 revolutions. And then that gave me 0.0625 revolutions per second squared. And then I changed it to radians, so it's 0.625 revolutions per second squared times 2 pi radians per revolution. That gave me 0.39 radians per second squared. And that is my forces and circular motion reassessment.